Benjamin, welcome to the podcast.
Thank you very much, and thanks for having me, for finding me. I'm excited to be here. Thank you.
You've worked with a number of exciting technology companies and partners over the past couple of years. You're currently a partnership lead at Atlassian. Let's
Yeah.
talk a little bit about you first. What did your journey over the past couple of years look like?
Um, my journey over the last couple of years, so I wasn't prepared for this, so thank you for asking and showing interest. Um, Maybe I can go back as far as having worked for eBay out of the UK and out of Germany, where I conceptualized, built, and took to market new partnerships, technology partnerships, business partnerships to generate additional revenues. And that went really well. After that, I joined Accenture. And Accenture, I was for a little bit more than 5 years, and I was an innovation lead, so always putting together 3 to 4 teams and going into very large customers and building centers of excellence for innovation. During that time, I learned that anything that we took to market, any new innovations, product services that we took to market that were data-based, intelligence-based, were the most impactful. And I really discovered my passion for data and analytics and machine learning and AI and GenAI back in those years. And that was a really fun engagement. My last incarnation, if you will, at Accenture was to manage the partnership between Accenture and AWS. I had a lot of fun there. I did this for a good while. And then I changed over to AWS. There were great growth opportunities for me there. And I handled a GSI partnership, so one of the large global system integrator partnerships for AWS in EMEA. That was half of my job, and the other half of my job was to drive AI sales, data sales, and that went really well as well. Did that for 3 years, and I've recently, beginning of January, so a little bit more than half a year ago, joined Atlassian. And at Atlassian, I'm again running and managing a partnership with Accenture in Europe. That's going really well. And there again, and also following my own passion, we have developed a big focus on AI and GenAI because Atlassian has launched very powerful solutions in that space. Can talk about that a little bit later, maybe. But yeah, so that's a little bit about me.
Fascinating. Thank you so much for
Thank
that.
you.
We, of course, going to talk about a couple of areas related to Gen AI in the automotive context. But starting on a higher level, how would you describe the state of Gen AI in automotive, especially given that you work with a number of
Yeah.
industries and large players?
Yeah. So I see a lot of potential in several new or newer automotive fields. Um, and this can be, of course, autonomous driving, and we can talk a little bit about how GenAI can enhance the autonomous driving capability genesis. We can also talk about the general ways of working in the automotive industry, because the automotive industry is more and more pivoting towards producing software and not only cars. And therefore, it probably makes sense to talk a little bit about how automotive companies are more and more adopting modern ways of working, which is pioneered usually in the software development cycle, Agile, just as one keyword, and then is kind of spreading across other fields of engagement. And then ultimately, I think it's worth talking about regulation. We've had the European AI Act implemented just a few days ago, which is a large piece of regulation. It's complex, but has very, very good intentions. So maybe those are the three areas that we can dive into.
You mentioned autonomous driving there.
Yeah,
Autonomous driving has, of course, initially probably, I don't know, at least 10 years ago been part of our CASE acronym with connectivity, autonomy, shared, and electrification. And since then, autonomous driving, especially level 4, level 5 on a larger scale, seems to have been always at least 5 years away and now potentially even more than that, how do you think Gen AI could potentially change the field of autonomous driving in automotive?
I think that the different levels, especially level 5, a lot of people say that for sure we will never reach level 5. I'm not so sure. I think I've seen the potential of technology and how fast it can develop and fast the development can accelerate. So I think that L5 can be upon us, maybe later than we all want, but maybe earlier than we all think. And I think we need to be prepared for that, and regulation plays a big part there. So how does GenAI really enable the capability or the development of the capability of autonomous driving? You know, you have those SDSs or self-driving systems that are being trained. And what you can do with GenAI is generate synthetic data that you can use to train those models, which means you no longer have to collect real data to train those SDSs, those self-driving systems, but rather you can use LLMs, large language models, to generate data en masse that is optimized for training those self-driving systems. That is a huge saving in cost, but it also actually enables more intense training, larger volume training than you could ever do, feasibly do with real data. So that is one thing. So synthetic data generation en masse. Then there are these so-called edge cases, the unlikely cases that nobody really thinks of when training any system, for example, a self-driving system. It takes me back to the joke. I don't know if it's funny, but the joke goes, a software tester walks into a bar and orders 1 beer, orders half a beer, orders -5 beers, orders 1 million beers and walks out. And then a customer walks in and asks where the toilets are, and everything explodes. So you don't always think of all of the cases that you need to take into account in a software training environment. Now, if you are developing an e-commerce website and a customer shows some behavior that is unpredicted, like, for example, asking where the toilets are in a bar, then if things start to malfunction, that's okay. Nobody dies. In the case of self-driving systems, we're talking about person safety, people safety. And of course, we need to have much higher standards when it comes to excellence. So edge cases are really, really important. Unlikely cases that can still happen, and where a self-driving system needs to react in real time and be excellent. And you can generate those unlikely data sets for training for these SDSs. Now, you can generate them in terms of actually generating the data, but GenAI can also think of unlikely scenarios that we would never think of as software testers, as software trainers. And then, of course, you can also use it to augment real data. So a lot of real data is being used in training self-driving systems. This can be augmented. It can be classified, it can be enhanced, and all of this is really, really helpful. It accelerates the training cycles, but it also expands the training volume and the amount of training that you do. So all of this is really, really helpful when it comes to autonomous driving. And I almost compare it to another industry where similar things are happening, which is in healthcare, life science, and in drug discovery. You know, it used to be that drug discovery happened in a lab where engineers, chemical engineers, and pharmaceutical engineers would come up with a molecule and test it, and then see if it's effective, and if it's not, it's discarded, and they come up with a different molecule. These days, you can synthetically design molecules and virtually simulate their effectiveness and thus predict the effectiveness of molecule designs in a purely virtual environment, which means all of a sudden you're not testing one molecule, but you can test millions of molecules. So I'm always comparing it to that. You really accelerate the testing, but you also do testing at a much higher volume, if that makes sense.
That's super helpful. On a similar sort of vein, there are lots of conversations related to onboard versus backend LLMs at the moment.
Yeah.
What is this conversation about? What are some of the use cases you see, and what are some of the advantages and disadvantages, etc., that organizations should be aware of?
Yeah. So I think LLMs, they are vast systems, right? The benefits of, and especially the training of LLMs and the ongoing training of LLMs. So if you have an LLM sitting in a high performance computing environment, for example, in the cloud, which is scalable on virtually to any level, and you can keep training it and basically consume massive amounts of compute, networking, and storage. And that is all possible in the cloud. It is not possible on a mobile phone or on a car. You have very limited, physically limited environments where you can only have a certain amount of compute and networking and storage. And therefore, you can develop these so-called light models that are highly, highly specialized. And that is kind of the light LLMs. And then you have the, let's call them back-end LLMs that are high performance, very large in volume. I think when trying to decide what you need, there's probably a hybrid solution that takes you the furthest. On one hand, you need to train those self-driving systems in a high performance environment and then port them into a self-driving car. The train system into self-driving car. But what you can also do is you can use a light LLM on board inside of a physical car to keep learning. And I think this could potentially be the solution. So a hybrid approach of large language models, truly large language models, and lighter LLMs on board could be the solution here. Now, the technical implementation isn't all that easy because those two LLMs will eventually have to talk to each other. Will have to talk to each other potentially at very high speed and with no lag. So there are a couple of technical challenges here, but I personally think it probably makes the most sense to employ both types of LLMs in a hybrid approach.
Have you seen any, just on the same topic, any useful or good use cases that organizations have employed and have potentially insights into how they have assessed the use cases? And then also, I guess there's always this question of to what extent should we work with external partners for the development of certain ones? Are there any thoughts you could share in terms of best practices you've seen?
Yes. So I think, first of all, it's really, really important to work with partners that can provision different LLMs. What you can do these days is you can train one LLM, but then use a different LLM from a different company, originate from a different company to validate the training. And you can have basically 2 or 3 or 4 different LLMs, even the large major ones, run in parallel, do the same kind of training and see which model will arrive at the better data, or if they arrive at the better insights and learning in conjunction. So I think that it's really, really important to not just use one particular model. And I'm still talking about self-driving systems, which need to be near perfect before you make them available. So I think combining different LLMs to do the same job and see which one comes up with a better result, and that might be different every time. That's probably a good approach and a good use case. And then, of course, you have specialized partners. They're not necessarily technology producers, but the consultants, the global system integrators. Accenture is one example. It's the biggest and the most successful in my view. That can help you along on that journey, because if a company has done this several times, they can kind of port the learning into your organization rather than you having to learn from scratch.
Mm-hmm. Where do you see the role of some of these new, I guess, potentially Gen AI native, if that's even a thing, companies like OpenAI? Do you think companies will develop some of the capabilities and LLMs that they use for some of these really critical use cases internally, or do you think they might rely on some of the models that are externally provided by companies like OpenAI?
Yeah. So I have a fairly clear view there. I think for any company that is not specialized in doing this and doesn't have the funding to do this, I think it's near impossible to come up with high performance LLMs or GenAI systems without breaking the bank. Coming up with LLMs themselves is not all that difficult, and there's so much out there and available. But training it, the training itself, it's a huge effort in terms of technological knowledge, personnel capacity, but most of all, really cost and compute and storage and networking. So I think it will break the bank of most companies if they were to try to generate their own LLM and train it.
Mm. A term we hear a lot these days is explainable AI.
Yeah.
What is explainable AI and what does it mean for organizations?
Um, Absolutely. So explainable AI, you have LLMs that just work, that work really, really well. And they've been trained again and trained some more. And they just work really, really well. But what often happens is that inside the black box of the, how it actually works, our views are starting to blur, which means we are not fully able to explain how an LLM works 100% and all the time, which is also the reason why we haven't yet eliminated so-called hallucinations. So an LLM giving you results that sound entirely plausible, but are entirely untrue. I think hallucinations are a big problem, especially when it comes to high performance environments and environments where people's lives are at stake, whether it's in self-driving or in military conflicts or anything like that. So I think the black box problem or the unexplainable AI that we have out there, and most well-known large language models have some level of unexplainability. I think that's a big problem. It's a trade-off with a huge amount of training that's been done, with a huge amount of data that's been fed into those LLMs. Because those LLMs, they're fairly smart and they evolve themselves. And it's just very, not necessarily the architecture, the foundational architecture and software architecture, but they do evolve. And then you kind of lose track of how it works. So explainable AI is something that's incredibly important and a huge challenge, especially in environments where people's lives are at stake. And of course, when it comes to regulation as well, regulation does demand that you can have fully explainable AIs and AI systems. So it's a huge problem and it's not solved.
Definitely coming back to the aspect of regulation in a moment.
Yeah.
Sticking to explainable AI for now, just one final question is related to, do you have any sort of practical guidance for organizations, especially the incumbents, either using GenAI tools or developing GenAI solutions when it gets to explainable AI?
Yeah. So I think my advice to companies that are using GenAI, whether it's in the automotive sector or anywhere else, is my advice is be curious. Just do it. Do it in a safe and do it safely. Make sure that you have your data safety security at the heart of everything that you do. but go ahead and find those use cases, experiment, succeed, fail, quantify your return on investment, and talk about it publicly. That is really, really important. So I think we can, I'm quite optimistic about us being able to generate a huge amount of return on investment in business value when using AI, GenAI, and the LLMs. But you have to do it safely, and you will have to be okay to fail. And you cannot do it with people's fates or lives at stake.
That's super
So,
helpful. Yeah.
yeah. Mhm.
Moving on to regulation,
Yeah.
we're based in Europe, and the European Union has been leading over the past couple of years, at least some experts would argue, in the data space with GDPR as one of the critical regulations, and now very recently has brought to life the EU AI Act. First of all, what are your sort of thoughts on this initiative, the regulation?
Yeah.
Do you think this is clear for organizations? And what do you think are some of the sort of practical steps that organizations should take now to, of course, ideally comply or at least manage the uncertainty and risks associated with the regulation?
So, Europe is indeed at the forefront in many ways when it comes to protecting people from data security incidents and let's call data and decision incidents where AI can make decision over people's lives and their fates. You know, just an example, if you apply for a mortgage, if you want to buy a house, it's hardly a person that makes that ultimate decision. It's automated systems. So automated systems are already telling you whether you can buy a house or not, which can have a huge impact on your life.
Mm.
So I think we all need to be protected as end users and as organizations from the reckless use of AI. I think I salute the first effort in launching regulation. The European AI Act has been implemented a couple of days ago. There are lots of companies that we work with that are proud to already comply. It is a challenge. It means investment. It means that you can't do certain things. And I think that is okay. I think totally broadly speaking, industrial self-regulation has hardly worked, especially when there's so much money at stake. So I'm a big fan of regulating it. Can we learn and do it better? Absolutely. To me, this is version 1, but it's good to have a version 1 implemented and live. So I'm a big fan of that. Ultimately, and that's a little bit on regulation in general, I think we could do ourselves a favor by not so much looking at use cases when it comes to regulation, but rather at human rights and people's rights and consumer rights. You know, you can easily develop new technology that can do new things that then need to be regulated anew, and it takes years, sometimes decades, to you know, launch a regulation. And you know, right now we are trying to regulate GenAI. What is when we de facto AGI, so general intelligence, going live, artificial general intelligence going live, then you have to launch a whole new set of regulation. But rather, if you focus your regulation on human rights, on their integrity, on consumer rights, and on organizational rights, I think we could be much more effective when it comes to regulation. I'm going off on a tangent, but I think it's an important point to make.
No, it's fascinating. Just to clarify the terminology here for listeners that aren't aware, what is artificial general intelligence?
Yeah. So artificial intelligence, put in very simple words, is something that seeks to imitate, replicate, and exceed a human intelligence. Right now, even LLMs and GenAI, it's very, very it is limited in its application. It is limited in its strengths. It can do certain things extremely well, much better than we can, and much faster and at a much greater volume than we can. But it's still GenAI, generative AI, meaning it generates content, it understands content, and all of that. AGI really seeks to replicate the full span of human capability and exceed it. So we're talking about the next level of LLMs. I think kind of a step between what we have now and full AGI is probably self-prompting GenAI. We have examples of that. I've played around with them. It's very, very impressive. But it's still not AGI. So yeah, that's maybe explaining AGI in very short words.
No, thank you for that. Initially, you mentioned that Gen AI has potentially profound impacts on how organizations develop software. Of course, software is a huge part of the automotive industry now. Lots of organizations refer to them now no longer as car manufacturers, but technology companies.
Yeah.
First of all, let's maybe talk about incumbent software organizations first. How do you feel about the state of some of these big incumbents and how they set up their software organizations? I know, for example, Volkswagen developed Carriot, and pretty much equivalence is what we see across the entire spectrum.
Yeah. So yeah, let's go back to the automotive industry. So automotive industry is pivoting more and more to what's software production, like you said. And there's so much to be learned. There's a big question of, do I build it myself? Do I buy it off the shelf? You know, I know so many car manufacturers that come up with their own version of Google Maps, and they'll never be as good as Google Maps, for example. So that's a lot of learning here. Then there's a whole learning around ecosystems, partnerships, technology partnerships. How can they be implemented? How can software and automotive companies get partnerships? And then there's the whole, for many software companies, new effort of producing software at scale. Having, tens of thousands of developers. I know, pretty much all German large car manufacturers and American ones and the Japanese ones. They have more than 10,000 software developers each. And their work needs to be top level. It needs to be really high quality. And you need to adopt and learn the different best practices that have been in use in the software development industry broadly, and port it into the automotive industry. And that's a huge challenge. But you can bring in outside talent to do that for you. You can use the industry standard tools that you use for collaboration, for example. And I'm shamelessly plugging Atlassian here, of course, with Jira and Confluence, where we are the industry standard when it comes to systems of work of the software developer experience and collaboration. And talking about GenAI, we have launched a product we call Rovo, which is a GenAI powered new product that helps software developers, and in fact, people that just work on projects, collaborate, coordinate. It's part connected enterprise where it sees all information, understands it, not only within the Atlassian platform, but really everywhere, whether it's Google Drive or Outlook or Slack or whatever systems you use. And then you can understand that content and interact with it conversationally. Rovo also can break down epics into stories into sub-issues. It can talk to you about the actual value of different activities that software developers do. It can show you the rationale and reasons why Rovo decided this is more valuable than the other thing. So it's really, really powerful, and we see more and more companies showing huge interest in that and using it. And even within POCs that take only a couple of weeks. We've just recently done one with Accenture. We could prove out and quantify enormous benefits when it comes to the quality of the work that's being done, when it comes to time savings. So huge amounts of savings and improvement of quality and time to market. So I'm done plugging Atlassian now and Accenture. I'm very passionate about it, so apologize about it. But I think the short answer might be that there's a lot of best practice out there. And automotive companies are well advised to look at those, learn from those, bring those in-house. There have been a lot of problems in establishing your own software houses inside of car companies. I'm not going to comment which ones, but they've been all over the news. And I think this is long and painful learning, and you could probably do better in learning faster and with a little bit less friction.
That was super helpful. Two more questions from my side. You mentioned you've spoken about the transformation in terms of agile ways of working and the potential impact of GenAI on them. I was just curious because I see and talk to lots of organizations that currently either don't leverage GenAI at all across their software development lifecycle, and on the other hand, we seem to have all of these suppliers, including and partners, including Atlassian, including AWS, including GCP, etc., that work on all of these solutions. Do you have any practical guidance for managers, directors in charge of the data and AI organizations at large incumbents in terms of how they could approach and get their teams essentially ready and essentially, after all, improve the efficiency and effectiveness and potentially even employee job satisfaction?
Yeah. So my advice is prerequisite is always data security and safety. But once you have navigated and complied with these requirements in what you want to do, just do it. You can get access to products and services and GenAI and LLMs at a fairly low cost. You can experiment with it yourself. If you have a capable team, you can use advisors that help you there. But ultimately, my advice is just do it. And like I said, in just a couple of weeks, you can prove out and quantify and extrapolate huge savings, huge gains in quality output or in output quality. And I think we can talk a lot about GenAI and all the benefits it brings. And a lot of it is hype. But once the hype has settled, ultimately what counts is the return on investment. And I think if you want to be a pioneer inside of your organization, comply with the data security and safety, but after that, just do it and succeed and fail and talk about both. And I think that's how you can contribute towards the learning and the openness of your organization towards GenAI.
That's super helpful. Are there any final thoughts or recommendations you would like to share?
Yes. I think one final thought that, and maybe we can talk about this in a different session, or maybe you with somebody else. But what's really, really important is that if you do these POCs, those trials, those pilots, have a keen eye on the developer experience and the user experience in general. And I don't only mean in terms of their output, in terms of the quality, the speed, the increase in volume of work output, but have a look at their happiness. And it sounds a little new agey maybe, but I think ultimately that's super, super important. So if you can take away a lot of the undifferentiated heavy lifting of a software developer, the research that they need to do, the logging, the reporting, the admin stuff that they need to do. If you can take all of that away and just get them to be productive and creative and collaborative, get them to talk to each other, get them to teach each other, get them to learn from each other, I think that is a huge benefit of GenAI as well. So ultimately, GenAI has the potential to increase the happiness of your software developers, of your employees. It has the huge potential to make you a better employer, a more attractive employer. And I think that that's a good implementation of GenAI. That's close to my heart.
Thank you so much for joining me today, Benjamin. It's been a fascinating conversation.
Hey, thank you very much, Fabian, for having me, and I look forward to listening to my own voice when this gets published. It's been fascinating to talk to you. It got me thinking about a couple of things a little bit more deeper. So as always, it's been a learning experience for me as well. And thank you very much. Look
Thanks
forward
for your
to seeing
time and
you.
insights. I much appreciate it.